All right, in this video, I want to take a look at what happens when we pass arrays into methods or into functions, and this is going to be a little bit different than how primitive types work, like we're used to. So let's go ahead and take a look. All right, so this first function, this doesn't really do anything important here. It just takes an integer value in, adds 3 to it, and returns that same value. So it should be pretty easy to understand. Returns an int, and so when I make a call to that method, I made a variable m, and I passed m into the change it, and I store that value returned in n. And so remember, change it adds 3, and when we run it, I get after I run it, I print out m and n, and m is still 5, and n is 8, all right, as I expected it to be. So that'll make sense. But let's look at another function I have, and this time I'm taking an array of values, and I'm going to return an array. And so what I decided to do in this is just go through the array and just take each element and double it, and then I'll return that. So it should return an array with all the values having been doubled. And so if I want to call it, right, one thing that so here's my array, 1, 2, 3, 4, 5, and I'm going to pass it off to the change array function, and it's going to return the new array and store it in nums2. And let's print out nums2 and see if it works as expected. And it does. Okay, so, but the weird thing is, let's go ahead and print out nums and see what happened there. All right, so what we see here is that nums actually doubled as well. And so to understand what's going on there, let's take a look at what's happening inside the computer's memory. So let's take a look at a line of code where we declare just a small array of ints. And so I'm calling that array nums right now. So here's what's actually going on in memory. All right, somewhere out in the computer's memory, there's going to be a sequence in RAM where the numbers 1, 2, 3, 4, and 5 are all stored. And then we made this variable nums. And so here's the nums variable. And just what we have to understand is nums is not a location in memory that is containing this list, but nums is containing a reference to this list. And really it's just like a pointer. All right, so it's the, inside here is just the memory address of where that list 1, 2, 3, 4, 5 is stored in the computer's memory somewhere. So, but there isn't a container called nums that has this list in it. And so, what does this mean? Well, when we have a function like, we want to do stuff, and we send nums off to it, right? We didn't actually pass this list of numbers, right? What we did is we passed that arrow along. And so, when we get to another function that's like, we'll do public void, and here's our do stuff function, and let's say it takes an int array called vals. Right, values is not a copy of this list of numbers 1, 2, 3, 4, 5. This vals, all right, that when nums get passed into vals, we actually just pass the arrow in. And so therefore vals is just, right, so now we've got this vals variable, and vals is just also pointing to this exact same place in memory. So that's why whenever we do any manipulation to the values array, like if I said vals 0 plus equals 3, well, I manipulated this. Okay, and then once I exit the do stuff function, if we wanted to check in nums again, we'll find out that num0 has also would also reflect that change, because nums and vals are actually just containing references to the exact same place in memory. All right, now that I'm back, and we see that that's what's going on in memory, one little quick thing that tells us is that it is not necessary, actually, if you want to manipulate an array inside of a function, you don't even need to have a return type. So in this, this first one, I returned an int, but here I left my function void, and I passed in values. And so let's say I wanted to set all the values to 7. All right, we have to remember values is now just containing a pointer to the array I passed in. So if I've got my change array to function, I'm going to pass in my list of nums here. And notice how I'm not storing it anywhere. I'm just passing it in. And even though it's a void, right? And there we have it. So, and just, one thing to think about is it's generally a good thing that you're not passing all of the values into a function. It's probably a good thing that we're only passing a reference to, passing a pointer to this list of numbers in the computer's memory, because, let's suppose this list were millions of digits long. There's a lot of memory overhead there. So anyway, all right, so that's how that works. Let's take a look at one more example with arrays passing. And this is just to show maybe a common mistake that you could make. So let's say we wanted to find the median, right? The middle number in a set of values. One of the things you may realize is, well, the easiest way to find a median is to sort it. And so here's a line of code that takes a list and sorts them in ascending order. And so, right, this is real simple here. It's just I check to see if I have an odd number of values in the list, then I just have a specific middle value, which is the length divided by 2, and I can return that. And so I guess this would be if I have an even number of values, I have to take the two middle numbers. So it's the length divided by 2 and then the length divided by 2 plus 1. And those would be the middle numbers, and I can return that. So, right, so this is a pretty logical way of doing a median function. And so down here when I call it, let's look at I'll just comment these out for now. All right, so here's my list of numbers, and they're scrambled. And I want to find the median, so this function returns a median, and I'll print it out. And right, and okay, the median is 3, which is correct. But one of the things that we notice when I print out the array, it's sorted. And this may be a problem because maybe it is going to mess something else up, that we actually changed the order of these numbers, right? These numbers could have been on order for a reason. And so in order to avoid that mistake, what we're going to have to do, right? Let's say sorting is something we want to do in a function just to figure something out. What I did here, and this is a median function that will work without changing the original array, is I made a new array that's the same length as the one we passed in. And in this loop, I just went through and copied each value one by one into the sorted array. And then I could sort it. And then here's the same, oops, that should say sorted. But then I could sort it and check to see, and then find the middle element or average of the two middle elements and return that. And so now that I have manipulated the copy of values, we're okay. Values should be unchanged. And let's double check. And make sure this section works here. So, all right. And there we still found the median successfully. And then the array, right, is unchanged. Right. So I hope this helps you out when you are designing your own functions that are taking arrays as arguments, and should help you out when you are answering multiple choice questions or debugging code as well.